In 2022, there is no any question in part 2. In 2023, there is a good question. 2023, 7, C part. 2023, question number 7, C part. Read the paragraph. When a motor car runs with a uniform speed of 10 meter per second minus 1, that is 36 kilometer per hour, on a rectilinear road, the driver of the car sees a barrier placed at a distance of 4 meters. In this instance, he applies brake to avoid an accident. The time taken, the time that elapses from the moment of deciding that brakes be applied to putting the application of brakes into effect. That is, his reaction time is 0.2 seconds. Now, what are they explaining here? Now, this is it. First of all, here, always remember, if they have given something in kilometers per hour, convert into meter per second. How are you going to convert? Remember this. 36 kilometer per hour is equal to 10 meter per second minus 1. Remember this. If you remember this, you can convert n units from kilometer per hour to meter per second to kilometer per hour. Now, let's take, if they have given 72 kilometers per hour, and if they ask to find that in meter per second minus 1, how are you going to do? Here, put a fraction. 36 kilometer per hour is 10 meter per second. 10 meter per second. So, that is for 36, 10 means for 72, how much? Mekata mekanang ocharata kocharade. It is all. Mekata mekanang ocharata kocharade. இதுக்கு இவ்வளோண்டா இதுக்கு எவ்வளோ? For 36, 10 means for 72, how much? How are you going to do? In 72, how many 36? 1 time, 2 time, 2 into 10, 20 meter per second minus 1. Now, that is what you should do. How are you going to always remember this? 36 kilometer per hour is 10 meter per second. Now, if they give something in meter per second means they are given meter per second and they have told to find 7 kilometers per hour. Just I'm saying this type of conversion will be in mathematics. Just I'm going to say for your knowledge. Here, for 10 meter per second, what is it? 36 kilometer per hour. Then for 30 meter per second, what is it? 3 into 36, how much? 6, 12, 18. 3 into 3, 9, 10. 108 kilometer per hour. That's it. Note it down. 36 kilometer per hour is 10 meter per second. Okay, now we'll come to the question. There is a person. There is a vehicle traveling with a uniform velocity of 10 meter per second minus 1. He saw a barrier We show a barrier at a distance of 4 meters. Always have a picture. In physics, always have a picture. So you can easily solve the question. Uniform velocity rectilinear road. Driver of the car sees a barrier placed at distance 4 meters. In this distance, he applies brakes to avoid an accident. The time that elapses from the moment of deciding that brake be applied to putting the application of brake into effect, that is, its reaction time is 0.26. Now, this person who is inside this, who is driving a vehicle, is seated, no? Is seated like this. So, once he sees this barrier, he thinks in his mind, he thinks there is a barrier. He won't calculate the distance. In 4 meters, there is a barrier, so I should apply this brakes. This should be deceleration, so I can stop it from knocking this. He won't be calculating it inside the mind, but he will have a knowledge. No? It is what no. So he will be seeing it. He will see the barrier. So he will think, now I should apply brake. I should now he will be keeping his leg in the accelerator, and he will be moving with velocity of 10 meters per second. Once he sees the barrier, he will take his leg from the accelerator and he will try to keep the leg on the brake pedal. So the time taken for this person to take the leg from the accelerator to press on the brake pedal is what is known as reaction time. Reaction time means he sees this and what is his reaction? It is his observation. From the observation, what is his reaction? Taking leg from accelerator, keeping the leg on the brake pedal. This is what is known as reaction time. So during that reaction time, what could have happened? So that is what is known as reaction time. The reaction time is 0.2 seconds. So during this 0.2 seconds, what will happen to this vehicle? Now he is taking and then he's moving now. During this 0.2 seconds, what will happen? The car will be moving to a distance of, let us take D1. Let me take as D1. And during this 0.2 seconds, car here is a traveling distance of D1. And it took a time of 0.2 seconds. Okay, so here also it will be moving with 10 meters per second. Still it's in motion, no? Still brakes are not applied. Still no deceleration. Still 10 meters per second minus 1. This is what is said. This is what is happening. So at this point, he will be keeping his leg on the on the brake pedal. So he will be decelerating. Sometimes he will knock the barrier. Sometimes he will not knock the barrier. If he stops the car before, if he stops the car before, yeah, if the acceleration that he has given, if the car stops before this barrier, he won't be knocking the barrier. But if his acceleration is lesser, if he do not press the brake pedal much with a force, with a greater force, then he will knock the barrier. So that is going to be the questions will be related to it. Will he knock the barrier or will he not knock the barrier? This is how the questions will be asked. So what are they asking? In C, Roman number 1, find the distance traveled by the car during the time of 0.2 seconds. They are asking this D1. So what is this D1? You know the velocity is equal to displacement divided by time. So they are asking this D1. The displacement is V into T, that is velocity into time. What is the velocity? Velocity is 10 meter per second minus 1 into time is 0.2, that is 2 meters. 2 meter, yes, 2 meters. Therefore, here initially he is at a distance of 4 meter. His reaction time is 0.2. So during his reaction time, he has traveled a distance of displacement of 2 meters. So what is this distance? Displacement. Here, from here to here, he has traveled a displacement of 2 meters. Now what is the distance remaining? 2 meters remaining. If the acceleration that he has given, and if he to stop the car before 2 meters, he won't knock it. If he stops the car after 2 meters, then he will knock the barrier. This is the barrier. So we'll see it. So find the distance traveled by the car during the time of 0.2 second. Retardation applied by the brake was 40 meter per second minus 2. Distance traveled under that retardation till the car stopped was 1.25 meter. Could the driver avoid the accident? Yeah. Now, here the remaining displacement is 2 meters now. What this person is doing, he is applying brake, he is decelerating, and he stops at a distance of. Now, what this driver is doing, he gives a deceleration and he stops at a displacement of 1.25 meters. He stops at a distance of 1.25 meters. Here, velocity is 0. So, will this car knock the barrier? No, it will not knock the barrier because the displacement is 2 meters. He stops the car at 1.25 meter. Therefore, he won't knock the barrier. So, what should be the answer? No, he won't knock the barrier. What they have asked, could the driver avoid the accident? Yeah, yes, he will avoid the accident. They haven't asked the answer. They have asked yes or no. You give yes. If the mass of the car was 1000, sorry, if the mass of the car was 1000 kilogram, what was the force applied by the brakes? You can solve this. He's decelerating. Because he's decelerating, we can find the what? We can find the acceleration. If I found the acceleration through F is equal to ma, I can find the force. So I'm going to clean this. Now let me clean this part. Let the diagram be. So what's the equation I can apply to find the acceleration? You can see time is not given. Therefore, v square is equal to u square plus 2as. This is, let us take A, this is B, and this is C. From B to C. From B to C, I am applying v square is equal to u square plus 2as. What is the final velocity? That is 0 square. Initial velocity is 10 square plus 2 into, he is decelerating. No, let me, I don't know this decelerating or accelerating. Just I'm going to find this A no. At the final answer, I will get it whether it is plus or minus. So let me put as A. And what is the displacement he has traveled? 1.25. Therefore, I'm going to take this to the opposite side. 10 squared is equal to minus 2A into 1.25. What is 2 into 1.25? That is 1.25 into 2. 2 into 5, 10. 2 into 2, 4. 5. 1 into 2. Therefore, 2 into 1.25. Yeah, what is 10 square? 10 square is 100. 100 is equal to 2.5a. That is minus. Therefore, minus a is equal to 1000 divided by 100 divided by 2.5. How can I solve this? I can take, I can multiply this by 10 and I can multiply this by 10. If I multiply, this will be 1000. 2.5 into 10 means 25. In 25, how many 25s? 1. In 100, how many 25s? It is 4. Therefore, 40 meter per second minus 2. 40 meter per second minus 2 is going to be his deceleration. His deceleration. So in the question it is asked, what is the force the person applied by the brakes? F is equal to ma. What is the mass? Mass. Mass is 100 kilogram. And what is the deceleration? It is going to be 40. So force is 4000 Newton. Force is, yeah, mass is not 100 kilogram, it's 1000 kilogram. 1000 into, what's the 40? Yeah, for 40,000 Newton. You should put the units. For simplification, they give 1 mark. For final answer, they give 1 mark. We'll see the next part. Seventh question, right? C part, A part done, B part done, now the C part. Explain by a calculation whether the accident could have been avoided by applying the above force in an instance where the reaction time was 0.3 seconds of a driver who was sleepy or under the influence of liquor. When he is addicted to liquor or when he is sleepy, the he will be like sleepy now. So he will take more time to take his leg from accelerator and to keep and to pedal the brake pedal. I'm going to clean this part. If you want, note it down. So now what's happening? The response time is 0.3 seconds. He is moving with the same velocity. Now the response time is zero point 0.3 seconds. If his response time is 0 0.3 seconds, then it is obvious that the vehicle would have moved further away. The vehicle will not move 2 meters, it will move further. Let's calculate the distance. What's the equation you can put to find the distance? Here I can put to find, yeah, S is equal to ut plus, what's the equation I can put? We can put speed is equal to distance divided by time, right? Or the velocity is equal to displacement divided by time. So what is the distance traveled? Let us take this as d2. d2 is velocity into time, 10 into 0.3, that is 3 meters. So 3 meters now. Now he has moved a distance of 3 meters. Now car will not be here. Car will be somewhere here. So now the time taken is not 2 meters, It takes 3 meters. Take 3 meters. An earlier question it is said a force is given and he will be moving a displacement of 1.25 meters and he will come to rest now. Now in this where the reaction time is 0.3 seconds, they are asking whether this car will knock the barrier. Now here the same force is given in the backward direction by applying the same brake, same deceleration, same force is acting. Therefore, the same distance will be traveled now also. The reaction time has increased from 3 meters, from 2 meters to 3 meters now. Now, when he apply the same deceleration, he will have a distance displacement of 1.25 meters now. Therefore, now he will have a displacement of 3 meter plus 1.25 meter, that is 4.25 meters. This 4.25 meters now here from the initial position to barrier there was distance of 4 meters now. But now this car is traveling, is stopping the vehicle at 4.25 meters. This 4.25 meters is less than 4 meters. This car will drop beyond the barrier. Car will stop beyond the barrier. So it is, therefore you can say that this car will not be barrier. So you should solve all this and you should solve. Here we should solve this, and to solve this to solve this and to calculate this, they have given totally 2 minutes. To identify this due to distance, 3 meters, and to show this, 3 plus 1.25 is 4.25. This 4.25 is greater than 4. Therefore, total distance traveled is 4.25 meter. This 4.25 meter is less than 4 meter. It will knock the barrier. Vehicle couldn't be stopped. Will meet with the accident. That's it. 2023 is over. All the part 2 questions, last 10 years part 2 questions is discussed under force. Then the next part will be started. What is the next part? Equilibrium, turning effect of force will be started.